Okay, we are on to the intervention for Concept 19.1, the application of circles. And this is one of the more complicated problems we've looked at this year. This takes lots of steps. And the thing to remember is go through each step slowly, really take a look at it. You just have to be careful. The math itself is not that complicated. It's keeping track of all your steps. So let's jump in. Week 19, Concept 19.1, application of circles. So you're told that you have a circle with an area of 81 pi centimeters. Here's your piece of information, 81 pi centimeters. And you're asked this question: what is the circumference of that circle? Well, here's what we know. Circumference is equal to 2 times pi times the radius. Which means if this circle has an area of 81 pi, and the area formula is area equals pi times r squared, the key is right here. The key is the radius, because that's the unknown. We know what pi is. It's 3.14. They tell us right here. You know in the circumference formula what a 2 is. The unknown thing is the radius, and that's what we have to solve for. So let's get started on it. We're going to take our formula for area, pi times radius squared, and we're going to make it equal to what they told us the area of this circle was. They told us the area was 81 pi. And now we're going to solve a multi-step equation. Let me get my red pen here, because this is what we've talked about doing in the past. Putting this line down, everything you do on one side, you have to do on the other. So that we look for something that's similar. And what's similar on both sides to start with is pi. If we divide by pi, just like if we had 9 over 9 or 5 over 5 or negative 3 over negative 3, top and bottom the same, that equals 1 whole. So pi divided by pi, 1 whole, 1 times r squared is r squared. Pi divided by pi, that's 1 whole. 1 times 81 is 81. Now the question that you're thinking, let me do a little thought bubble right here. Now the question that you're thinking to yourself is, what number times itself equals 81? And if you think about it that way, you probably figure out it's 9. 9 times 9 makes 81. So if r squared equals 81, what we're technically doing is we're taking the square root of r squared, we're taking the square root of 81, and we're figuring out that r is equal to 9. So we have our radius. Now we can take that radius and we can plug it into this formula. We know r equals 9 now. So if we go back to this formula, what we have is 2 times 3.14 times 9. We'll do the 2 times 9. 2 times 9 is 18. So 18 times 3.14. And that, let's grab our calculator, and that is going to equal 18 times 3.14 is equal to 56.52 centimeters. It's not squared centimeters because it's circumference, it's a distance around. So there is our answer to the first part, to part A. Now, you can see we've already gone through lots of steps just to get there. So again, none of the math we did was really complicated. We did the problem solving, equation solving, dividing by the same thing, getting a big 1, multiplying out. It just takes the steps. All right. So now, let me get my calculator out of the way. Now we're ready to tackle part B. In part B, they say if that circumference was increased by 35%, what would be the radius of the new circle? So we're going to start by taking our 56.52 and we're going to multiply it by 0.35. Because 0.35 is 35% as a decimal. So 35% is equal to 0.35. So let's multiply that out. 56 point, my calculator's down in the lower corner here if you didn't see it. 56.52 times 0.35 is equal to 19.782. And that's not our answer, that's the increase. That's how much it's growing by. So we need to take our 56.52 and we need to add 19.782. So 19.782 plus our 56.52, and that gives us 76.302. That is our new circumference. And you might think, man, it would be great if the problem was just over now, but it's not, because we need to find the radius. So we're going to take that. Let me get my calculator out of here. So we're going to take that new circumference. Let me draw a line to separate problem A's work from problem B's work. We're going to take that new circumference of 76.302, and we know that that's equal to 2 times pi times r, because that's the circumference formula. Let's start dividing this by 2. We can pick anything that's common here. So we're going to divide both sides by 2. Here's one of those big ones. Get my calculator up. I'm going to cover some of my former work, but that's all right. You can rewind, or at the end I'll take the calculator off in case you didn't copy that down. Let's clear this up. So we have 76.302. We're dividing that by 2. And that gives us a total of 38.151. And that's equal to pi times the radius, because we got rid of the 2. Scroll a bit here so there's a little more workspace. All right, screen's not big enough for all my stuff. The next thing we're going to divide by is pi. Now over on this side we're going to show it as pi because that's how it sat in our formula. I could have changed it to 3.14 earlier. Over here we're going to do it as 3.14. So we have 38.151 divided by 3.14. So 38.151 divided by 3.14 is equal to 12.15. 12.15 equals 1 times r is r, and there is our answer to the second part. Let me write it over here with its label. Since it's all in circumference, the answer to the second part is 12.15 centimeters. All right. So, again, complicated problems. Take a look over this one. Let me get rid of my calculator. Let me scroll back up so you can see everything. Take a look at this one and then tackle number 2. If you had this one right, fantastic. Just move on to the explanation for number 2. Been to problem number 2. So in problem number 2, this time they're starting us with a circumference of 30 pi, and they want us to find the area of the circle. So here's what we know. We know that circumference is 2 times pi times r. That's what circumference equals. And we know that in this problem, that equals 30 pi. So once again, we are going to solve by doing division. So we're going to divide first by pi. Here we go. Here we go. Those divide out. We end up with 2r equals 30. Divide both sides by 2. Here's our big one this time. And we end up with r is equal to 15. It's kind of a funky looking r, but it is. R is equal to 15. Well, that's not the answer. That'd be nice if that was our answer, but that's not, because that gets us ready for this. We know that area is equal to pi times r squared. So we can substitute what we now know. We know that this is 3.14 times 15 squared, which is equal to 3.14 times 225. I could have gotten the calculator out, but I know what 15 squared is. Now I'm going to get the calculator out because I don't know what that times 3.14 is. And we have 3.14 times 225 is equal to 706.5 meters squared. That is the area of a circle whose circumference is 30 pi. So that's part one. Part two. We need to increase this by 60%. So we're going to have a 60% increase on this. So let's take our 706.5, and we're going to multiply that by 0.6, because 60% as a decimal is 0.6. So we've got our 706.5, and we're multiplying it by 0.6, and we get a 423.9 increase. And we always have to make sure that we don't look at that and say, oh, that's the new amount. No, that's the increase. So now we need to take, come on, pen, don't fail me now. There we go. 706.5 plus 423.9 is equal to, 423.9 still in my calculator, plus 706.5 equals 1,130.4. That's the increase in the area, so that's now meters squared. And that's still not our answer because they want to know what's the radius of this. So let me get my calculator out of the way and let's figure out the radius of this. So we're going to take this. We're going to take the 1,130.4, and we know that that is equal to pi times the radius squared. And the first thing that we're going to divide by, we're doing this again. So the first thing we're going to divide by on both sides is pi. Over here I'm going to call it 3.14 because that's going to work easier in my calculator. Let me put my calculator up in this corner while we work. So I know that dividing this side by pi gives me the radius squared now. Dividing this side by pi, 1130.4 divided by 3.14 is equal to 360. So I now have 360 equal to the radius squared. So I need to know what the square root of 360 is. On your calculator, this is one you would do with a calculator. On your calculator, you're looking for this key. Might have a little 2 here. but in most calculators it just has this thing. It looks kind of like a long division sign. It's not a long division sign. We call it a radical, and then the X underneath it. On my calculator, it shows up as this square root button right here. So what I'm going to do is I'm going to take the 360 and press its square root, and I get that big long number, which I'm just going to take the first couple places of that big long number. I'm going to go out 2 places, so that 3 tells a 7, stay a 7, and I get 18.97 is equal to the radius. And if I bring it over here, I know then that my new radius is 18.97 meters. And that is the answer to part B. All right, this is one of our longer videos because this is, again, this is complicated work. Doesn't mean you can't do it. It just means it takes a lot of steps and a lot of time. All right, if you have more questions, come see me. Remember, this is Concept 19.1, which means you can also review the Week 19, the Week 20, and the Week 21 test to see these kinds of problems worked out.